Hey guys, by the end of this video, you will learn exactly what a RAG AI agent is and how to make one inside n8n without no code. Nowadays, it is really simple than you think. Now be ready with your n8n instance and some API credits in OpenAI so that we can use this LLM inside our workflow. And well, how do we search information right now? We basically do it in two ways. One is we search through Google, or we search through ChatGPT, Gemini, or some other LLM platforms. It spits out what we are looking for from the vast database that it has, which is obviously the whole internet. So where does this RAG fit into this? Here we are giving the AI agent a specific data set to look through depending on our requirement. So RAG stands for Retrieval-Augmented Generation. Basically, the AI agent searches the database or where we save the data that we want to search through. Then it retrieves the data depending on your question, and this complete data will be shared to an LLM, and this LLM will generate accurate and correct answers for our query depending on the document that we shared into its database. There is a confusion regarding the RAG agent and the vector database. So basically, a RAG agent has nothing to do with the vector database, but we use the vector database because it is very efficient and fast for retrieving information. For this RAG agent to work, we need to add and then retrieve information based on our query. So we need to have two workflows. One is to put data inside the vector database, and the next one is to retrieve the data from the vector database. So how do we put data inside a vector database? So initially consider a PDF with a lot of text data inside it. So first stage is we have to chunk it up, and we have to use something called a data loader to get it done. During chunking, it actually splits the total text into small blocks, maybe like 1000 words or something per chunk. By that way, it has been made into a lot of small parts. And next, all of these chunks will be going through an embeddings model, where each of these chunks are given a specific set of numbers or numerical vectors associated with it. Each of these vectors are dispersed inside a vector store based on some mathematical constraints. That is how we pump the PDF data inside the vector store. Basically, inside a vector database, the similar data is actually clustered near to each other. Or you can just have a visual understanding of how the vector database looks like. So each of these details, for example, the bananas has a set of numbers associated with, and nearby these green apple or pears are actually situated. These actually comes in a broader group of fruits. So these things will be placed close to each other. Similarly, ships and boards will be clustered near each other, and in the same case football, and also if we have a volleyball or something, it will be placed near the football here. That is how the data gets dispersed inside the database or vector database. In order to lock in this concept, let's discuss an example. Let's say we are adding the sales data of a fruit shop. At a point we are adding the sales data of orange. Basically, we'll have some information in text format about the orange sales. Next, we will split this data into separate chunks using the data loader. Then we embed, or we make, or we vectorize these chunks, different chunks, into numbers or a set of numbers, and next we place it inside the vector database, as you can see here. So the orange will come near the fruits. Now we consider all the required data is put inside the vector database. We ask the RAG AI agent, so how much kilogram of oranges were sold in November 2025. Now the AI agent will again use the embedding model and change this query, that is this text data, into a vector, and this vector will have a place near the fruits and especially near the orange. Why? Because the query has something to do with oranges. Now using some mechanism inside the vector database, it will collect the nearest vector points, and each of the data associated with these vectors will be passed to the LLM along with the query. Then LLM will go through all these data and then answer to our question in a very effective manner, so that it can say something like in the month of November 2025 we had a sales of 200 kilograms of oranges. Now LLM will go through the whole text including the query. Then now the LLM will give a very specific and accurate answer to us. So these are some of the examples or relevant applications of the RAG agent. instead of going through a lot of data in different files or something, we can actually take all this data and put it inside a RAG agent so that the doctors can easily access the patient history and related contents. And it has like a lot of applications in the medical field, as you can see here. And in the area of legal document review, we can make use of this RAG agent to go through different types of or different deep elements inside a document in a very user-friendly manner. So a lot of different things can be done. It all depends on your creativity and how you want to work with the RAG agent, and you can use it in multiple different use cases across all types of business needs. And now that we have a solid foundation, let's build a RAG AI agent. Let's go to n8n, add the first step, that is the trigger manually. Let's quickly build the workflow right now. Let's name it a RAG AI agent. So the first workflow will be to take the document and put it inside a vector store. So let's add a Google Drive node, that is a download file node. Let's create a new credentials. If you have already done this, it is pretty easy. For first timers, it is a little bit a long process. So basically we need a client ID and a client secret here. I have already done this in another video. I'm just attaching the video part over this place. It is a little bit long process, so I don't want to waste much of your time here. So now the credentials is ready. The operation is download, and from the list we have to select the file that we want to download and put it inside the vector store. Here I'm going to use a PDF which has the rules related to football. I have already uploaded the file inside my Google Drive, just searching football rules. So that is selected right now, and we are going to use a Supabase vector store for our purpose here, and we have to select add documents to vector store. Now we have to create a new credentials. Here we need to have a service role secret as well as the host address. So let's go ahead and find those things. You can read the documents and find it. Otherwise you can just follow me. Inside the Supabase you can just make a free account. I've already logged into my account here. Just go to dashboard, and inside the dashboard you select and just create a new project. Name it like test for now, and this password is important, so whatever you are putting it here, you have to save it somewhere else. You cannot see it other ways after this. And everything else is as it is, and just click on the create a new project. Once you click on this, everything is healthy, so that the project is ready to go. Now we have to make a vector database inside this. In order to do that, go to the docs, go to Supabase vector store, just scroll down a little bit. You can find something like a quick start for setting up your vector store. Just click on this. We'll be going to a page like this. Just copy this complete code. You don't need to type anything, and you have to go back to your project, and there is something like an SQL editor here on the left side. Just right click and paste it over here and just run. So meanwhile, let's understand what this is. By default, our table name will be documents, and if you want to make a different name, just change the documents and all other places wherever you can find documents. As you do like that, you'll be able to make a vector store of a name of your choice. And you don't need to worry about all these details here. Just go to table editor. So now we can see here something like documents. Now we have created our vector database inside the Supabase. You can see the ID, content, metadata, and embedding. That is a vector, and the content related to that vector or the chunks will be saved into the content here. So that is how the data is stored inside the tables inside the Supabase. So now that it is ready, we have to get the host address as well as the service role secret. Go to project settings. Here you have to go to data API. Just copy this particular URL and paste it over host And for service role secret, you have to go back to go to API keys. You can see legacy anon and service role API keys. Just go there. You can see the service role secret here. You can reveal this and just copy this complete text and just go and paste it over. Now just click on save and the connection is ready. It's that simple. Just follow whatever I am just telling you. You're good to go. The operation is insert documents. Inside the table name, you have to select the documents here, and embedding batch size, keep it to 100, doesn't matter. And inside this add option, you have to have something like this. So if you have changed your table name, you have to change that name here as well. So once this is done, let's set up the embedding as well as the data loader, which we discussed in the start of the video. So we have something like a default data loader. The data type is actually a binary data type because PDF is a binary data type. So rest of the settings you don't need to bother about it. Now the data loader is ready. In the embeddings model, you have to have an OpenAI embeddings. Click on it. I already connected my OpenAI account with it. It is very easy to do. Just copy a API key from the OpenAI and just paste it over here. And in the model, it should be like text embedding 3 small. The dimensions, it usually will be 1536. So if you have followed everything as I just told you, you don't have anything to worry about. Everything should be proper right now. Now let's tidy it up a little bit and let's execute this particular workflow. Now it is downloading the file, and yes, so you can see the Supabase vector store has successfully executed and it has like 182 items at the end. Now if we go back to our project inside Supabase and you go to table editor, you go to documents, you can see the same number for 182 different rows here. It's in the next page. As you can see, it is 182 rows, and each of these rows has a certain text associated with it. You can just see like this. So this is the chunk of text that is associated with this particular vector, and the vector, you can see here, every chunk has a different number associated with it. So this is how it is stored inside the Supabase. Now we have to make the RAG AI agent. So let's build that. Now we have to add a chat trigger as well as the AI agent here. Add a brain for this AI agent, that is the ChatGPT OpenAI chat model, and just select GPT 4.1 mini. You're good to go. Keep everything else as it is. Inside the tool, you can just search Supabase and select Supabase vector store. Here you just connect with the same credentials you have set up prior, and then in the description I can say something like use this tool to search for rules related to football, and you can select the documents here, and limit, let's set it as 4. Everything else same. You can change the documents name. If you have given a different name, you have to change this here, and you are good to go right now with this particular node. Now we have to give the embeddings for this as well, because we have to embed the query and compare it with the nearby vectors inside the Supabase vector store. What we can do, we can actually connect this with the same embedding, that is the OpenAI embedding that we used for our first workflow, but we have actually did not do one important thing. We have to actually give a system message for this AI agent to work efficiently in a way that we want. So we can just go to ChatGPT. I have already created a prompt. Just create it very easily. Just ask, makes me a simple but effective system prompt for the AI agent. It needs to search through the vector store tool, that is a Supabase, connected to it whenever a chat input is received. It's basically acting as a RAG agent. So it is like a basic prompt I have given to ChatGPT, and it has made me the system prompt. So depending on your use case, you have to arrange the system prompt in a better manner so that it suits your specific needs. Yeah. Then we have to copy this and just go back and just paste it over here. Now we are perfect and good to go. Now let's ask a question here. What is meant by advantage in football? Now query that advantage in football is passed to the Supabase vector store, and collect different text pieces from that. You can see these 4 responses, response 0 and response 4 related nearby contents has been taken. You can see all the details here properly. So now it has worked properly. We can ask some other questions like what is the requirements of a football? What is the requirements of a ball? The requirements of a football for a football are: the ball must be round, it must be made of a safe and suitable material. All the details which are directly coming from here. See, that is the beauty of this RAG AI agent. So whatever data you feed it, it can go through all this data and give us a proper output in a very fast and efficient manner. So there is a problem right now. Basically, it cannot remember anything that we have already discussed in the chat. So if we ask any related questions to those, instead of just going to the chat history, it will again use the vector store. It will go through the vector store and retrieve it again and again and again. So in order to tackle this, let's give the AI agent some memory. So click here. You can have something like a simple memory, which is a native to n8n, but here we are going to use Postgres chat memory, which is a little bit advanced production grade, and we are going to use it here. Here you have to have a new credentials. Inside the Postgres account, we have to have certain details. For that, we have to go back to Supabase, and you can see a connect button here. Just click on this and go to transaction pool or transaction pooler under a direct connection. Here you can see like this, and you have to click here to see all the details of the Postgres that we are going to connect. Go back to RAG AI agent. It needs host. So actually the host value is this. You can actually click here to copy this, paste, and here you have to give the password that you have given in the project. So I hope you would have saved it somewhere, so you can reuse it here. Everything is ready. Click on save. If you have done everything as I've just told you, so the connection would have been successfully made. Now you can give the context window length, like how much chat the Postgres or the AI agent should remember. So it is here 5. You can give more or whatever you want. So everything else is as same. Now that the RAG agent is completely ready, I hope you enjoyed this video, and also I was able to provide some value to you. So if you like this video, please hit that like button and also subscribe for more related contents. So see you next time, guys. Peace out.